So, let us see what an RF signal generator is, how it works. Let us see the block diagram of it, the applications and the specifications of a RF signal generator. So a signal generator is a vital component in a test setup and in electronic troubleshooting and development, whether on a service bench or in a research laboratory. So signal generators have a variety of applications such as checking the stage gain, the frequency response, alignment in receivers, and in a wide range of other electronic equipment. They provide a variety of waveforms for testing electronic circuits, usually at low powers. The term oscillator is used to describe an instrument that provides only a sinusoidal output signal, and the term generator to describe an instrument that provides several output waveforms, including sine waves, square waves, the triangular wave, pulse trains, as well as amplitude modulated waveforms, frequency modulated waves. Hence, when we say that the oscillator generates a signal, it is important to note that no energy is created. It is simply converted from a DC source into AC energy at some specific frequency. So there are various types of signal generators, but several requirements are common to all types of the generators. The frequency of the signal should be known and stable. The amplitude should be controllable from very small to relatively large values. Finally, the signal should be distortion free. All these requirements vary for special generators such as function generators, pulse generators, and sweep generators. These AF and RF generators are designed to provide extensive and continuous coverage over as wide as a range of frequencies as is practical. In RF generators, additional provision is generally made to modulate the continuous wave signal to provide a modulated RF signal. We can get amplitude modulated. Also, we can get the frequency modulated signals. So most of the service type AF generators commonly cover from 20 Hz to 20 kHz. So let us see what a signal generator is, what is RF signal generator, block diagram of RF signal generator, and working of RF signal generator. So vital component in a test setup in electronic troubleshooting and development. It is used for alignment in receivers to check the gain of the amplifiers in receivers. So requirements of signal generators. You need a signal frequency, controllable amplitude, distortion free signal, and these are the different frequency bands. The audio frequency band, as we know, it is from 20 Hz to 20 kHz. The radio frequency from above 30 kHz. High frequency band is from 1.5 to 30 MHz. The very high frequency band 30 to 300 MHz. The ultra high frequency band from 300 to 3000 MHz. The microwaves beyond 3 GHz. So this is an RF signal generator to produce the different waveforms at radio frequencies. So this is a sine wave RF signal generator. So what is an RF signal generator? So RF signal generator is nothing but it generates the radio frequency signal. You have seen what the radio frequency range is. So it generates sinusoidal output at a frequency from 100 kHz to 100 MHz. It contains an RF oscillator, that is radio frequency oscillators, amplifier, a calibrated attenuator, and output level meter. So you know high frequency oscillators are the Colpitts oscillator and the Hartley oscillators. These, there is an amplifier to amplify the signals. There is a calibrated attenuator to select the amplitude of the signal. Next is the output level meter, which indicates the output level. So this is the basic block diagram of RF signal generator. It consists of a frequency range and selection switch. You can select the frequency range. You can select the frequency range in different, which is marked in different ranges. And also that particular range again you can select the required frequency, the set level adjustment, the output level meter, and the attenuator output to adjust the amplitude. So RF oscillator contains a frequency control, as we told, to select the frequency. The frequency range switch, because the total frequency range will not be in a particular one range, but it will be split in different ranges. So you have to first select which range we require, then you select the frequency. Setting the output to desired frequency. Next, amplifier is there to adjust the output amplitude. It allows the voltage applied to the attenuator to set the calibration point on the output level meter. So the calibrated attenuator, the output will be reset to the calibration point for every frequency change. So whenever the frequency is changed, output will be reset to the calibration point. This is necessary to ensure the output voltage level as indicated in calibrated attenuator. Output level meter nothing but indicates the output level so that to ensure constant input voltage to the attenuator. This is the basic block diagram of an RF signal generator. As you see in this block diagram, we have basically an RF oscillator. As I told you, we can use a Colpitts oscillator or a Hartley oscillator. The output of the RF oscillator through an amplifier is given to the output level meter, then to the calibrated attenuator. The output of the calibrated attenuator is the required signal. So here you see internal FM source and external FM source. This RF signal generator also generates the frequency modulated signals. You can also get amplitude modulated signals. So an internal FM source will be present. So if you select the internal FM source, that particular frequency modulated signal will be generated. If you select external FM input, then the free signal which you are applying externally, that frequency modulated signal will be obtained. Similarly, internal AM source is there, external AM source is there. So when you select the internal AM source, so the AM signal will be supplied by the internal source and you get an amplitude modulated signal at the output. Supposing you have an amplitude, the modulating signal externally, you can apply the external modulating signal and you can get that particular amplitude modulated signal as output of the RF signal generator. Of course, we have the power supply to provide the power. Because these are all radio frequency oscillators that are high frequency oscillator generators. Internally, RF oscillator we have seen that in that particular block we can use a Hartley oscillator or a Colpitts oscillator. One more thing is, in the block diagram of the RF signal generator, each and every block is shown to be surrounded by the dotted lines, and overall the total block diagram is again marked in a dotted lines. These are nothing but it shows that each and every block is shielded, and overall the total RF generator is again shielded so that it's not influenced by the external magnetic and electric fields. Its frequency should be constant. Its frequency should be stable. It should not be interfered by the interference of electric waves or magnetic waves which are nearby to the RF signal generator. So it, it must be shielded so that it provides a stable frequency without the influence of these external signals. So as I told you, that RF oscillator which we are using in the RF signal generator is a Hartley oscillator or a Colpitts oscillator. They are nothing but radio frequency oscillator. They generate high frequencies. So this is the basic this is the basic circuit of a Hartley oscillator, which provides us the output signal across the tank circuit shown. And this is the Colpitts oscillator. We can use either the Hartley oscillator or the Colpitts oscillator as the master oscillator in the RF signal generator. So, as I told you, the types of modulated signals which we can obtain from an RF generator is the amplitude modulated waveforms and the frequency modulated waveforms. So, to obtain a amplitude modulated waveform, this is the basic circuit for obtaining the amplitude modulated waveforms. Here we have a low frequency input, that is the modulating signal is applied either externally or internally depending upon the switch position, whether you need the modulating signal externally or internally. You have to give the RF input and also provide a modulating signal, then you'll get an amplitude modulated output. This also amplitude modulated signal also we can obtain at the output of the RF signal generator. Similarly, this is a frequency modulated circuit. Here also we have a carrier frequency which is provided by the RF oscillator with the modulating signal as LF input. Then you get a frequency modulated output as shown in this figure. So basically, what for we are using a signal generator? It is used to generate the radio frequencies. We have an attenuator. Also, we have the amplitude modulated signals, the frequency modulated signals, and high frequency signals, which are useful to test a radio receiver or to test any electronic setup. So this is an instrument which can generate various RF voltages. It is used for alignment of radio and television receivers. This RF signal generator is used for testing of amplifier response. So as I told you, a signal generator basically is a vital component in a test setup and in electronic troubleshooting and development, whether on a service bench or in a research laboratory. So these signal generators have a variety of applications such as checking the stage gain, the frequency response, and alignment in receivers, and in a wide range of electronic equipment. They provide a variety of waveforms for testing electronic circuits, usually at low powers. The term oscillator is used to describe an instrument that provides only a sinusoidal output signal, and the term generator to describe an instrument that provides several output waveforms, including sine wave, square wave, triangular wave, and pulse trains, as well as they also generate the amplitude modulated waveforms, the frequency modulated waveforms to test radio receivers and the TV receivers. So, when we say that the oscillator generates a signal, it is important to note that no energy is created. It is simply converted from a DC source into an AC energy at some specific frequency. There are various types of signal generators, but several requirements are common to all types. The frequency of the signal should be known and stable. The amplitude should be controllable from very small to relatively large values. Finally, the signal should be distortion free. These requirements vary for special generators such as function generators, pulse generators, and sweep generators. These AF and RF generators are designed to provide extensive and continuous coverage over a wide range of frequencies as is practical. In RF signal generators, additional provision is generally made to modulate the continuous wave signal to provide a modulated RF signal. Most of the service type AF generators commonly cover from 20 Hz to 20 kHz, and the frequency band limits, as we have seen, for the audio frequency, the range is from 20 Hz to 20 kHz. For radio frequency, above 30 kHz. Very low frequencies, 15 to 100 kHz. Low frequencies from 100 to 500 kHz, and so on. So the microwaves are beyond 3000 MHz frequency. So basically the RF signal generator, it has sinusoidal output with a frequency range somewhere in 100 kHz to 40 GHz. So we have already seen the block diagram of an RF signal generator. It consists of a master oscillator designed for highest frequency range, and frequency dividers are switched to produce the different ranges. The highest frequency range of 34 to 80 megahertz we can obtain using amplifiers and different ranges. The master oscillator is tuned by a motor driven variable capacitor. For fast coarse tuning, a rocker switch is provided which sends the indicator gliding along the slide rule scale of the main frequency dial at approximately 7% frequency changes per second. Oscillator can then be fine-tuned by means of a large rotary switch, with each division corresponding to 0.01% of the main dial setting. The master oscillator has both automatic and manual controllers. The availability of the motor-driven frequency control is employed for programmable automatic frequency control devices. The internal calibration is provided by 1 MHz crystal oscillator. The supply voltage of the master oscillator is regulated by temperature compensated reference circuit. Here the modulation is done at the power amplifier stage. For modulation, two internally generated signals are used, that is 400 Hz and 1 kHz. So you, you can use either the internal or the external modulating signals. The modulation level may be adjusted up to 95% by a control device. So flip-flops can be used as frequency dividers to get a ratio of 2:1. As I have told you, in the block diagram we have seen the shielding. So the radio frequency leakage from a signal generator can create practical difficulties in measuring receiver sensitivities particularly if the receiver itself is not well shielded. So additionally, inaccuracies in attenuation at the microvolt level may result strong radiation fields exist. So to prevent one component from affecting another through their common electric or magnetic fields, we do what is called as shielding. If proper magnetic shielding is not provided to the main oscillator of signal generator, then there will be the provision of there will be chances of interference due to the radiation from the wires in the system. So this interference will affect the nearby equipment. So the radiation field effects are eliminated by using RF shielding in RF signal generators. Usually the shield is made with copper or aluminum and is fixed over the chassis. So mainly the shielding is used to prevent RF interference between the components, each block of the RF signal generator, to prevent emission from RF energy from any point except the output terminals, to prevent RF emission on the power line. RF chokes and capacitors are used. Let us see the specifications and applications. So signal generators output at a frequency from 100 kilohertz to 100 megahertz, contains RF oscillator, amplifier, calibrated attenuator, output level meter. This is the block diagram. So the specifications, when you speak about the specifications, the output frequency range can be from 0.15 megahertz to 50 megahertz. The frequency error must be less than 1%. The output impedance is 75 ohms. Output voltage 50 millivolts. Amplitude modulation to 30%. So you can also design RF signal generators with different frequency ranges varying from 50 kilohertz to 80 megahertz. The amplitude modulation, as I told you, maybe 30%. The output impedance, you can use either 20 ohms output impedance or the 40 ohms output impedance. The output voltage is 50 millivolts. The AF modulation, you can obtain the modulating signal as 400 Hz or 1 kHz. The power supply, you can use the mains 230 volts at 50 Hz. The external modulation source, the frequency is 0 to 5 kHz. The frequency error is less than 1%. Now if you see the applications, mainly the RF signal generator, it is used to generate different frequencies with different voltages to align and testing of radio equipment, testing of amplifier response. You can adjust amplifier response. You can align radio and TV receivers. So troubleshooting and repairing electronic devices, checking and testing various lab experiments, can generation of AM/FM waves for testing the communication receivers. It is used for the measurement of gain of each stage at RF frequency. Can also be used to determine the distortion characteristics of an amplifier. So alignment of radio and TV receivers. What you understand by alignment is we'll be using number of tuned circuits in a radio or TV. So when you change the stations, when you tune the stations internally, the tank circuit's frequency will be changed. So when 2 or 3 tank circuits may be connected through the same line, so that when you change or adjust any one stage frequency, all the other stages frequency must be changed in the similar manner. So that is the alignment. Alignment must be correct, or else the output will be distorted. So here, testing of amplifier response, alignment of radio and television receivers, troubleshooting in radio and television receivers, checking various instruments in laboratory, generation of AM, FM waves. So this is AM and FM using RF signal generator. So here, as I told you, the applications of signal generator can generate various RF voltages required for alignment and servicing of radio equipment, testing of amplifier response, adjusting of amplifier response, alignment of radio and television receivers, troubleshooting and repairing electronic devices, checking and testing various lab experiments, generation of AM FM modulation waves for testing communication receivers. It is used for the measurement of gain of each stage at RF frequency. It can be used to determine the distortion characteristics of an amplifier. So to sum up, RF signal generator is one which generates the radio frequency signals. Also, it generates the amplitude modulated signals and the frequency modulated signals, whether it is audio frequency oscillator or a RF signal generator or a high frequency oscillator. The several requirements, as we have seen, are it should give the frequency of the signal constant value. The amplitude should be controllable from the small to relatively large values. The signal should be distortion free. It should be stable. Generally, these RF signal generators are used for troubleshooting in our radio and TV receivers. So these RF signal generators are used for adjusting of amplifier frequency response, the testing of amplifier frequencies response, troubleshooting and repairing electronic devices, checking and testing the lab equipment, generation of AM, FM modulated waves for testing the communication receivers, measurement of gain each stage at RF frequency, can be used to determine the distortion characteristics of an amplifier. It can generate frequencies ranging from 50 kHz to 80 MHz. You can obtain depth of modulation of 30% with an output impedance of 20 ohms or 40 ohms. The output voltage is we can obtain 50 millivolts. The AF modulation 400 Hz or 1 kHz modulation. The power supply of 230 volts and 50 Hz. The external modulation source of frequency of 0 to 5 kHz and the frequency error of 1%. So I told you in the block diagram, each and every block is shielded, and overall the RF signal generator is totally shielded, so that the RF signals which are generated, which are used for testing purpose, must be of same frequency and amplitude, so that they should not affect the equipment which we are testing. So shielding is done so that the output of the RF signal generator is not influenced by the electric and magnetic fields which are present nearby, and also each stage internally also should not influence, it should not influence or affect the signals generated by this RF signal generator. So to prevent the RF interference between the components, to prevent the emission of RF energy from any point except the output terminals, to prevent RF emission on the power line, RF chokes and capacitors are used. So this is about the RF signal generator, which is which has so many applications with generation of AM wave, FM wave, and only high frequency signals. We can get all these signals using a RF signal generator so that we can use for laboratory purpose, for testing radio receivers, for testing the TV receivers, and the various applications we have seen for checking and testing a lab equipment, for troubleshooting the electronic equipment, alignment of radio and TV receivers, testing of amplifier response by varying the frequency of the RF signal generator, which can be given to an amplifier as input. You can check the output with varying the frequency at the input of the amplifier. RF oscillator also can generate various RF voltages required for alignment and servicing of radio equipment. You can use a RF oscillator for measurement of gain of each stage to RF frequency. It can be used to determine the distortion characteristics of an amplifier. So these are the various applications of an RF signal generator. Thank you.